This is rainwater. But when it falls on our cities, this is what ends up in our water bodies. Pollution builds up in our cities every day, containing microplastics from paints, tire particles, toxic hydrocarbons, heavy metals, and the list goes on. Every time it rains, a cocktail of these pollutants gets washed through our drainage networks and into our rivers untreated. In fact, 30% of all ocean pollution is mobilized by this very mechanism, making it one of the most urgent threats to our environment. And that's not all. With increasing downstream treatment costs, businesses are being charged for surface water drainage. And that's where Guerilla comes in. Guerilla is a retrofittable device that fits into existing roadside drains and captures this pollution at the first point of entry into the drainage network. When runoff enters into the device, it is separated into a concentrated slurry of contaminants that's left behind in the roadside drain, while a cleaner stream of water is allowed back into the drainage network. To make this happen, we have a patent-pending design that leverages a specialized internal geometry and the natural flow of the water using no membranes or moving parts, giving it a conservatively predicted lifetime of over 10 years. Currently, we have a working prototype that we've tested out in controlled environments with simulated runoff and have been able to achieve 98% efficiency for particle sizes of 100 microns and above. Unlike the competition, Guerilla retrofits seamlessly into the existing roadside drain infrastructure and their current maintenance protocol, making it the only affordable, scalable, and sustainable solution of its kind. With increasing number of regulations being brought in across the world, the global market size for runoff management is estimated to reach £27.8 billion by 2031, of which 4.6 billion is estimated to be the UK market. And with water-related agendas taking the limelight, we believe that this is the perfect opportunity to operate in this industry. With our focus on customers that own and manage roadside drains, primarily local councils, water companies, and landowners, we offer a tailor-made subscription-based service with tiered access to hardware and real-time data insights, providing ongoing customer value. And with lower pollutant and sediment loads into our water streams, Guerilla is able to help its customers with reductions in their trade effluent and surface water drainage components of their water bills, offsetting the cost of our device. We're a spin-out from Imperial College London and the Royal College of Art, with the founding team coming from diverse backgrounds spanning across design, engineering, business, and marketing. Alongside us, we also have the support of our advisors, who are industry-leading experts in the field of runoff management with decades worth of experience. We're also backed by various incubators and organizations across the UK and have built strategic relationships with partners to help every step of our pipeline. Currently, we've secured a field trial partner and we'll be testing our device in situ on a high-traffic road in London over the next couple of months. This is in line with our plans to be ready for manufacturing by Q2 of next year, for which we're looking to raise 450K before the end of this year. So get in touch with us to see how your support can help us get one step closer to building a more water-resilient future. Thank you.
Well done, and we welcome your team member from Guerilla. Right, time for audience questions. You'll see the QR code back on your screen. And let's start the one while we're waiting for them to come in on how often you need to replace the device.
Yeah, so essentially, we don't hold any of the contaminants within the device itself, but they drop to the bottom half of the gully pot, which acts as a buffer unit. And then the current infrastructure that already exists with the gully sucker, a massive truck with a vacuum in the back, comes and collects it. And we've estimated with the roads, with TfL having the most polluting roadside drains, would take about a year to fill up in the space that we have below.
Brilliant. We've had a question in about how much expertise is needed to change the filters.
Yeah, so going back to the previous point, you don't have to change the filter itself. It's just a matter of pulling the device out, collecting the contaminants from underneath, and putting the device back in. So we've tried to reduce the amount of effort that needs to happen from the drainage maintenance point of view and fit within the current maintenance regime.
Brilliant. We've had a question in asking, have you thought about adding filtration at a higher throughput downstream?
Yeah, so one of the main reasons we do it at this stage is because 90% of the pollution actually can be pulled out by just pulling out suspended solids, because at this stage, many of the chemicals that diffuse into the water through the drainage network are still attached to the suspended solids. So basically, we're using a physical process at this stage to pull out these. Otherwise, you'd need a chemical or an electric process much further down the line.
Which councils in the UK are already on board, asks one audience member, if any?
So right now we are we kind of secured a partnership with Earl's Court Development Company. So their development site span between two councils. So it's South Kensington, Chelsea, and Fulham, Hammersmith and Fulham. So these will be the two councils that we'll be collaborate with during the field trial.
Fantastic. Okay. What do you do with the filters after use?
Yeah, so going back to the previous point, we don't have to change out the filters. So we've predicted a lifetime of over 10 years with the kind of materials that we're using to create the device itself. So it's a matter of not changing the filters, but just collecting the contaminants that collect at the bottom.
And does it impact water flow?
Yeah, so essentially the flow rate through our device is actually 1.5 times that of the outflow pipe within the roadside drain that currently exists. So we wouldn't be the bottleneck, it would be the outflow pipe within the roadside drain itself.
We have a question in asking what type of filter you use.
Yeah, so I'm going to answer that in terms of the technology. So because it's patented or patent pending, I won't be able to reveal much of it, but essentially we use capillary action and centrifugal separation as part of the philosophy that we use here.
Brilliant. Does the design have to be bespoke depending on the drainage system?
So right now, all the TfL roads has a more standardized design, and that's what we used to design our prototype, the working prototype. But we designed the product in a way that's modular, so it's adapt to different design and dimensions. So make it more scalable as well, so we can have a global market.
Brilliant. How are the pollutants disposed of?
Yeah, so we're trying to fit within the current maintenance protocol that already exists, trying to reduce the barrier for entry. And as part of that current maintenance protocol, the gully suckers actually take these contaminants to a wet waste treatment facility where they're processed. But in the future, we're looking at actually mining for materials from these because of the value of the materials that might be there.
And that brings us to time. Thank you very much indeed. Well done.